is still the same thing that we were doing yesterday. I can solve a system of equations by substitution. So that's the method we're going to still use again today. And then this one that we actually started doing yesterday also, setting up your own system of equations and using it to problem solve. So solving that system of equations that you set up yourself. Notice what it says today though. Not only are we going to solve, but we're going to check. Okay? So we are going to check our answers in our homework today for the ones that are not word problems. Okay? So number one. There are 4 different possibilities every single time when you look at the equations and neither of them are solved for x or for y, which is the case here, right? X minus y, or x or y alone? X minus y, no, they're not alone. 2x plus y, either of them alone? No, so we really have 4 possibilities. We could take that first equation and solve it for x. We could get the x alone. Or we could take that first equation and we could get the y alone. Or we could take the second equation and we could get the x alone. Or we could take the second equation and get the y alone. So everybody in here gets to make their own choice. Which one are you going to do? But here's what you want to do. You want to become like some critical thinkers and say, what would save me the most work? What's going to create less work for me than if I did it, try it. So process through that first. So what do you think? That first one or the second one, and which one should we solve for which? I just really want to make it a one-step thing if I can, and I don't want to make it very hard for myself at all.
First one.
First one for what?
We should put y on the other side.
Yeah, let's get the x by itself, which would mean we'd have to get y put on the other side, right? So if we want to solve it for y, that's actually 2 steps, because when we move the x, we would have a negative y. Can't have a negative y, we have to have a positive y, so then we'd have to do another step. So
just add y.
let's just make it as easy as we can on ourselves, and let's take this first equation and get it solved for x. We're going to add y to both sides. And we are going to have x by itself now. And this is really the same as what? Negative 3 plus y is really what?
Y minus 3.
Negative 3y because it's a multiplication. It could be y minus 3. Let's just make it y minus 3. You can leave it as negative 3 plus y. You can write it as y plus negative 3. Or you can clean it up and make it y minus 3. So now we have the x alone. We have our substituting expression. And remember, once we have that, we go to the first step of our problem, which is take the other equation, can't use the same one, take the other equation, and because this expression y minus 3 is really the same as x, we're going to sub it into that equation for x. So we're going to have 2 replaced by, that x is going to get replaced by y minus 3. And then we're going to bring along all the rest of the equations still, plus y equals 12. So what happens when we have to take 2 times y minus 3? Yeah, it's distributive property. And what's the product of that? What do we get? 2y minus 6. So we're going to have 2y now, take away 6, add that y equals 12. We have a lot to do. We have to do check problems too, so don't be writing in, 24 font. Or Hunter's 6 font. Okay, what does that simplify to? 2y minus 6 plus y, what does that simplify to? 3y, because it's a 2y plus another y, so 3y minus 6 equals 12. Okay, if you haven't jumped ahead of me yet, finish solving that for y. Get it solved for y, and then we will go on to solving for x. I get 6. Anybody else? Get 6? Okay, looks like Lots of you did? Okay, so we're feeling pretty good about that. Okay, then step 2 says we're going to go get x now. Well, we might as well use this. X equals y take away 3. And we'll substitute in for that y. What are we going to put in? 6. So our x value is
3.
3.
Step 3, 3, 6.
And ordered pair is our step 3. We write our solutions for x and y together as an ordered pair. Ordered pair is 3, 6. But today we're going to check that. But when we check it, remember we always do check problems in the original name of the equation. Always. So whether you like that or not, that's what we're going to do. So check. And we have to do this in your homework today. So let's start with the first equation. Remember, we're not going to take its new name we gave it. We're going to take the name it started with. X take away y equals negative 3. What's going in for x?
3.
3. What's going in for y? 6. And we finish this. 3 take away 6 is negative 3. Bring down our equal sign. Nothing to do on that other side but bring the negative 3 down. Does it check?
No.
It checks. We end up with an equality, so it checks. But it can't just check in one of them. It has to check in both of them. So now we're going to do 2x plus, no, what is it? 2x, yeah, 2x plus y equals 12. So we're putting 3 in for our x and 6 in for our y. And we're legitimately going to evaluate down. What is 2 times 3? 6. And so we have 6 plus 6 on that side. 6 plus 6 is 12. And it checks. So we're feeling confident about our answer. If we graphed it, what would happen on the graph?
It would just land there.
That's the point that they would meet, where they would intersect. Ordered pair 36 would be where they should intersect. So if I ask you to solve it both ways, you better get the same solution both ways? Yeah, it only has this one solution. Okay, any questions on Isaiah?
Can we check our answers by graphing?
Can we check our answers by graphing instead of algebraic checking?
Yeah.
If you want to. If you want to go through that much work, sure. But you need to legitimately graph the lines and then see if they actually intersect at that point, not work from the point of intersection backwards. That would be a true check problem, would it? Are you accusing me of thinking like you? Is that what that was?
Yeah, I never ever would ever do such a thing. I've always gotten my homework done.
Okay.
And legitimately too.
Okay, I guess we can move on. It's Friday. To watch your notes, girl. Okay, number 2 on the back side. Let's look at this system of equations. Are either of the equations solved for x or y?
Yes. Or no.
No. How many choices do we have? How many different things do we do? 4. Okay, let's start evaluating which ones make sense. This is kind of like, this is just a thought process you need to go through without doing all the work. And you need to follow along with me because sometimes you're going to make this so much harder for yourself than you need to. Okay? So if we solve that first equation for x, our final step would be having to divide by what? 2. Because we're going to get the x alone, our final step would have to be dividing by 2. So let's look at those other pieces and see. Would 4 divide nicely by 2? Yes. Would 20 divide nicely by 2?
Yes.
That might be a good move then, huh? How about if we solve that first equation for y? Don't even worry about signs right now. Let's just worry about if we were going to solve that for y, what would the final step be? Dividing by 4. Okay. 2 divided by 4. 1/2. Do you really want to create fractions when you don't have to? No. So throw that one out. We're not going to solve that first equation for y. It's just going to create a fraction. How about the second one? If we solved it for x, what would be the final step getting x alone? dividing by 4. Is 16 divisible by 4?
Yes.
Nice. How about 32? Yes, nice. Okay, so that's another possibility. How about solving the second equation for y?
Yeah.
What would be our final step?
Dividing by 6.
Dividing by 16. 4 divided by 16. 1/4. You want to do that?
No.
No. Okay, so it looks like the y's are kind of out of the picture here. We need to either solve the first equation for x or the second equation for x. If we would choose the second one, we could work with smaller numbers, couldn't we? Yeah, let's do the second one.
But isn't it,
Does it matter? No. Isaiah?
wouldn't it be easier to work with the first one because then you would have a bigger fraction?
We shouldn't have any fractions if we solve for x. We
No, I
just
mean like solving for y later on.
Possibly, but I still think you can go ahead and do the other one. Solve the first one for x, Isaiah. I know you want to be a rebel. Go.
No,
Just do it. Just do it. Go. Okay. See if you get the same answer as us, though. Okay. So what are we going to do to both sides first?
Add 16y.
Add 16y, because remember we're trying to solve for x. So we're first going to get this equation solved for x. And what are we going to do next?
Divide everything by 4.
Divide every piece by 4. So 4x gets divided by 4. 32 gets divided by 4. 16y gets divided by 4. Our equation is now x equals, what is that? 32 divided by 4. 8. Get those calculator brains going. No calculators, just brains. 4 and y, right? Okay. So now we have one of the equations solved for x. We can say, you know what? This expression right here is the same as
X.
x. So we're going to go and start our first step, which says take the other equation, and I'm going to change it to add the opposite right away, and substitute in your 8 plus 4y for that x. And we'll solve this equation for y. Okay, go, get it solved for y. You can do it. You know how. I don't need to help you.
I could hear my little brother through that.
Remember that first step is always the most painful. It takes a long time. But we got y equals what?
1.
1. Okay. If you didn't, try and figure out where you went wrong. I have mine up there for you. The second one will be a whole lot less painful because we're just going to substitute into our x equals 8 plus 4y. And we're going to see what happens with that. And the solution is ordered pair 12, 1. But now we have to check it. And where do we check them? In their original names. Well, the one never did get renamed, but the other one did, but we don't use its new name, we use its original name. So let's start with our 2x minus 4y equals 20. Maybe better known as 2x plus negative 4y. And the reason that that's kind of important to do is especially when those x's and y's are negative, it just helps us. This time I'm not, but, so we're gonna put in our x value of 12 and our y value of 1 and see what happens as we evaluate our way down, as we simplify using order of operations. 2 times 12? 24. Negative 4 times 1?
4.
Negative 4.
Negative 4, I mean.
24 plus negative 4? 20. Well, checks out in that one. And you do a complete full check problem. I'm done stamping papers that are only partial effort. And the rest of it is stored in your head for some reason. Okay, so then our other check problem would be 4x, and I'm going to change it to add the opposite, plus negative 16y equals 32. We put our 12 in for x. Thank goodness it's the 4 we get to take times 12, not that 16. And negative 16 times 1, and we're supposed to get 32 on the other side. Four times 12 is? 48. Negative 16 times 1?
Negative 16.
Negative 16. Bring down our equals 32. $48, you give 16 of it away. How much money do you have left?
32.
$32. 32 equals 32. It legitimately checks out. So we are feeling good about our solution of 12, 1. Ordered here, 12, 1. Okay. So Isaiah, when you check that one on the graph, where should it intersect?
It's seriously a 12 one.
Yeah. Did you do the problem using the other equation?
No,
Oh.
it was too difficult. I erased it and took it over.
Anybody else do it with the other one? You got carried away and decided to. Oh, shoot, I was kind of hoping somebody did. Okay, let's take a look at number 3. We're going to problem solve this setting up a system of equations. Well, in our system of equations, we're going to have x's and y's. When we have x's and y's, we have to do what? Name them, describe them, tell what they are. So, see if you can figure out what x and y should be in that situation. Read it to yourself, and then decide, what do I think x should be? What should y be? Little hint, whatever they're asking you to find, that's probably the unknown. So what can x be? What about CDs? How many there are?
Cost of the CDs.
Cost of the CD. We already know how many each of them bought, right? What we don't know is how much should they cost. So we have to be more specific and not just say is CD, it is the cost of a CD. Well then if X is the cost of a CD, what is Y? Cost of a DVD or DVD cost, yeah, is the cost. Again, we know how many DVDs they bought. We don't know how much they cost, each of them.
So CD and the DVD are different?
Yes.
They are, but they aren't. I mean, you know, it's kind of like,
One's a movie, one's music.
typically that's the way they are, yes. Okay, let's do some of a system of equations now to problem solve this. To figure out how much a CD did cost and how much a DVD did cost. Morgan?
3x plus
Equals 20. Okay, so tell me where you got that, Morgan. 3x plus y equals 20. Where'd that come from?
the 3 used DVD for CDs.
Okay, so 3 times the number, or the cost of a CD. 3 is the number she bought times how much each of them cost. Okay, plus what's the y? She bought one DVD at a cost of Y. Do we really need that one in front of the Y? No, and equals 20. Why is that?
It's for 20. So it's 20.
She spent a total of $20. So money, how much money she spent on CDs plus how much money she spent on DVDs should add up to how much money she spent altogether. Okay, the other equation. Blaine?
3x plus 2y equals 22.
Okay, you guys agree? Here we go. Ooh, Riley, what's wrong?
It should be 2x is 2y.
Oh, because Joel bought 2 used CDs and 2 DVDs. So the only thing we got to change on their Blaine is the 3 to a 2, right? We just got to change that. So it's a 2x plus 2y equals 22. Now can we go with that?
Yeah.
Okay. Are either of those equations solved for x or y? What would be the simplest thing to do? Get y alone on the first one. Let's do that. So we're going to take this first one and we're going to say, I want the y alone. I'm going to have to subtract 3x. I'm going to have y equals 20 minus 3x. I could leave it like that, or I could change it to negative 3x plus 20. It's totally your call. You can leave it 20 minus 3x. That's okay. You can work with it that way. Okay, now we know that a y in this problem is the same as negative 3x plus 20. So we can now go to work. We're going to do step 1, which says use the other equation and substitute into that one for y because we know what y is the same as. So we're going to put our negative 3x plus 20 or our 20 minus 3x, whichever way you're writing it, in place of that y. And we're going to solve that equation for x. Okay, go ahead and do it. Find the cost of the CD. A negative divided by a negative is a
Negative.
positive. How many 4s can you take out of 18? 4. How much is left over?
2.
2. What's 2 over 4 the same as?
4.
1/2, 4.5, right? This is money, so we'll talk about it in decimal form. So this is $4.50
50 cents.
is what we really have here, don't we? Okay. Now we'll go find the other one. We'll go y equals negative 3x plus 20. We know what x is now, so we're going to sub it in. But I'm going to leave the dollar sign off of it and the 0 just to make cleaner writing right now. Not negative 450. That would be giving you the CD for nothing. Whoopsie. $4.50 3 times is
13.
$13.50, and a negative times a positive is a negative. You have $20, you give away $13.50. How much money do you have left? $6.50. If I still own my grocery store, I'd hire Hunter to work at it. He can do math in his head. We'd have to count on the cash register to do it all at once. Okay, Do we write our answer as an order of carry this time?
No.
No, what do? We say the cost
Proceeding.
of a CD, okay, cost per CD, I think it like that, is $4.50, and the cost per
DVD.
DVD
$6.50.
is $6.50. End of sentence. And I'm not gonna make you do a check problem, please.
Yay.
But you do have to do everything else we did. We started by explaining, naming X and Y, describing X and Y, then we set up a system of equations. Yes, there might be other ways to problem solve this, but we're using systems of equations right now. And then we solved it. And then we wrote a sentence answer telling the world what we just found out. Okay, any questions?